Welcome to my video tutorial about cross-site scripting. In this tutorial, I will explain it, show you all three types, and demonstrate exploiting them. Stay tuned. Cross-site scripting is a vulnerability in websites or software. An attacker injects HTML or code, such as JavaScript, to make the user believe that the included code is part of a website the user trusts. There are various reasons for an attacker to exploit this vulnerability, but the most common are gathering sensible user information like username and password, or infecting PCs by spreading malicious code. Some guys also use it to deface websites. The DOM-based method is also called a local attack. This has the reason that the local web browser is tricked into executing JavaScript. If the arguments given to a page are used on the same page, an attacker could easily trick the browser to execute JavaScript. If you use, for example, JavaScript objects like document URL, location href, and document referrer for the processing of your code, an attacker can inject his own JavaScript code. This method works only if the user clicks on the prepared link the attacker distributes, either by spare targeting or by spreading it in public places like forums. If the user visits the website in a direct way, he won't get exploited by a DOM-based attack. To demonstrate how DOM-based cross-site scripting works, I've prepared a little website. As you can see in the code, I'm using the JavaScript object document referrer, which tells the user from which website he came from. Due to the fact that this is a vulnerability in the user's web browser, most browser distributors already fixed it. Therefore, I'm using Internet Explorer 11, in which this vulnerability is not fixed yet. If I click on the link to the page itself, the referrer is shown. If I alter the URL before clicking on the link, the URL which will be displayed by the referrer object is also another. So if I click the link, the entered code in the URL is executed by the browser and the alert is shown. Other browsers are already patched. Firefox encodes the entered URL and so does Chrome. The vulnerability, which is left unpatched in Internet Explorer, is fixed in Microsoft's new browser, Edge. A not persistent attack can occur when unchecked user input is displayed without being encoded. This attack works only when an action was triggered by the user, like sending form data or calling an URL with parameters. The best example makes a search engine which displays the input on the next site without checking or masking it. If a user enters the web address directly without parameters, he won't be exploited by a not persistent attack. For this scenario, I've also prepared a demo page. It fakes a search engine. When I enter the URL directly, the page is displayed in a normal way. But when I insert JavaScript arguments to the search form, and click on Submit, my alert is shown. In this way, an attacker can execute any JavaScript code he likes. When I visit the web page by directly entering the URL, the exploit is gone. That's why this attack is called a non-persistent attack. You can talk about a persistent cross-site scripting vulnerability if two conditions are met. The user's input has to be written to the database without being checked, and the same input has to be displayed without being encoded. If those conditions are met, and if an attacker injected code, a user who visits the website in a regular way will be exploited. The user doesn't know that the code isn't from the website itself. That's why this is the most harmful cross-site scripting attack. I've created a guestbook to demonstrate how the persistent cross-site scripting attack works. As you can see, the values are inserted directly into the database without being checked. In addition to that, the entries from the database are displayed without being encoded. If I would be an attacker, I would have all the time I need to investigate the code and to write my own, which fits perfectly in the victim's page layout. I've prepared a little code snippet to exploit this guestbook. In my example, the address of the form action is my own local page, but in reality, an attacker can insert any address he likes. So I type in a fake name, a fake email address, and also some comment text, so it won't be clear at first sight that the injected code was submitted by my comment. After the comment, I paste my code and I click Submit. A pop-up is shown, which looks very similar to the website's layout. A regular user won't see the difference. The script behind the form action leads to a script which displays the login information. An attacker could sniff the data without letting the user know. When I reload the page, the injected code is still on the page. So when Serious Bob visits the guestbook, he is tricked into entering his login data. But when he does, the password is sent to the attacker, who can now easily log in into Bob's account.
If you are a coder, make sure to always check the user's input. If your website displays submitted content, encode it so attackers can't simulate to be part of the website. Web application firewalls are also a nice feature for your network. If you are a user, use add-ons like NoScript and keep your browser updated. And if you're not sure at all, investigate with tools like Firebug before entering your information. If you liked my video, please give me a thumbs up and subscribe to my channel. If you have questions or ideas for upcoming video tutorials, make sure to leave a comment. Thank you for watching and see you in the next video.